Okay, so this one, I guess this was the first lesson, but the text that you sent me, they didn't come in order. So 13.2, which is teaching what the angles are. So first of all, whenever you're dealing with angles, each angle has a point where it starts from. It has an initial side and a terminal side. So it starts from somewhere, it ends somewhere. Now, because we want to work with the x and y coordinates later on so that we can talk about the trig functions, we just see that starting position, I put it at the origin. We decide to put the initial side on the positive side of the x-axis, and then terminal side of the angle depends on its measurement, where it falls. Now, this is an agreement that if we start from the initial side, meaning if we start from the positive side of the x-axis and we move counterclockwise to get to the terminal side of the angle, then that angle is a positive one. But if we start from the same initial side, positive side of the x-axis, and move clockwise to get to the terminal side, then the measurement of that angle is negative. So we have positive angles, we have negative angles. For example, here I'm showing you that, look at the 90 degrees, the right angle. If I start from the x-axis and I move counterclockwise, then 90 degrees is a positive angle. But in red, I showed you that if I start from the initial side and move clockwise, then the angle that we measure here is negative 90 degrees. Same goes for 180 degrees, same goes for 270 degrees, and it's negative. And one revolution, which is the entire thing. So the initial and terminal side of this angle are the same. We start from the positive side of the x-axis. We go one full revolution, and then the terminal side is exactly at the same place. So we have positive 360 degrees if we go counterclockwise, and we have negative 360 degrees if we move clockwise. Quadrants are really, really important. Later on, when we talk about the trig functions, sine, cosine, tangent, and the other three, we definitely need to pay attention to the quadrants. So from now, just get used to it that we call these quadrant 1, quadrant 2 that I showed you in blue, quadrant 3 in green, and quadrant 4 in red. Now, what's so special about these is because any point that I take in quadrant 1, I know that its x and y coordinates are positive. Any point that I take in quadrant 2, doesn't matter where, as long as that point is in the second quadrant, I know that its x coordinate is negative and its y coordinate is positive because we have y up here and we have x here. Any point in the third quadrant, any point that we take, if we look at its coordinates, we have x is negative, y is also negative. And any point in the fourth quadrant has x positive and y negative. These are really helpful when we talk about sine and cosine and tangent, and then the three reciprocals. Okay, so here's one thing. Now, if we look at, let me see how to move this thing. Okay. Now we want to see when we talk about angles, how do we measure them? There are two units of measurement. Just like for length, there are several units of measurement, let's say yard, feet, inches, centimeter, all of those. For angles, there are also two different ways of measuring them. One unit of measurement is degree, the other one is radian. Now, if we want to convert from degrees to radians, meaning that what's given to you is an angle in degrees, what's wanted is the same angle, not another angle, the same angle, but this time in radians. So you're just converting units. If we need to do that, then we have to multiply the given degrees by pi over 180 degrees. You see that you want to get rid of the degree. So this is a good trick to think that whatever degree is given to me, for example, 30 degrees, I have to multiply by pi over 180 degrees so that I have 1 degree in the numerator for example, 30 degrees, another degree in the denominator, which is 180 degrees, so that the degrees cancel out. So here we get 30 pi over 180, which simplifies to pi over 6 radians. Now, if you're converting from radians to degrees, it means what's given to you is in radians. What's wanted is the same angle in degrees. This time we multiply by 180 over pi. Exactly the reciprocal of what we wrote earlier here. So for example, negative 4 pi over 5 radians. We want to convert this into degrees. So I have to multiply it by 180 degrees over pi, because degrees is what we want, so we put that in the numerator. So simplifying it gives us negative 144 degrees. Let's say we have 2.8 radians. So in this one, there is no pi, but it doesn't matter really. Whatever is given to us, this is an angle and its measurement is 2.8 radians. We are converting it into degrees. So 2.8 is being multiplied by 180 degrees over pi. We put it in the calculator because we don't know exactly what pi is, but calculator does. So this goes into the calculator, and whatever answer we find, that's the answer in degrees. Now, there is another subject, and that is what are the coterminals? Hold on. Okay, coterminal angles. The name implies what it means, coterminals. So we are looking for angles who share the same terminal side. Remember that the angles, they have an initial side, they have the terminal side. So coterminal angles, they start from the same point. They start from the origin. They start from the same initial side, which is the positive side of the x-axis. However, what's different here is that they have the same terminal side, but how do we get to that terminal side is different. For example, here in the first one, I'm showing you 45 degrees. Okay, so we started from positive side of the x-axis. We moved counterclockwise because this is a positive angle to get to this terminal side. Now, is there another way that I start from the positive side of the x-axis and end up with the same terminal side? Yes, of course, there are infinitely many of them. One of them here I show you with green. That's what's happening. Let me draw it more clearly here. So this is the terminal side that we want to get to. Therefore, I finish one full revolution, which is 360 degrees. And then from here, you see in the calculation also that I say plus 45 degrees. Why plus 45 degrees? What tells us that if we are adding or subtracting? The same thing that we talked about from the beginning, whether we are moving clockwise or counterclockwise. So I finished one full revolution from here to here. That's one full revolution. 360 degrees, and it's positive because it's counterclockwise. And then once I get to this point, I'm still moving counterclockwise, 45 degrees. Therefore, I add them. So you see this 405 degrees here. That's how we obtain it. But is that the only way? Of course not. It depends how many revolutions I cover. I just know that I want to get to this terminal side. And I know that the measurement from here to here is 45 degrees. Now, if I choose to complete 2 revolutions, here's one full revolution, here's 2 full revolutions, and then add 45 degrees. And again, adding because we are moving counterclockwise. So then I have 2 times 360 degrees plus 45. And that gives us 765 degrees. So as many revolutions as I want, I can add. And then at the end, just add 45 degrees. How about negative coterminals? Negative, it means that this time we are moving clockwise. So here are the x and y axis. Here's the angle 45 degrees. So we know that we want to end up with this terminal side, but for another angle. So this time, instead of moving clockwise, I'm going to move counterclockwise. Did I say it correctly? No, sorry. instead of moving counterclockwise for positive angle, I'm going to move clockwise. So starting from the positive side of the x-axis, I go clockwise. That's one full revolution. I'm not going to continue because I already passed this terminal side that I wanted to stop at. Therefore, what am I supposed to do? Go back. You see how it works? So instead of going and continuing and never stopping at this terminal side, I see that, well, from here all the way to here, that's one full revolution in the negative side. So that's negative 360 degrees. Now, once I get to there, I see that, oops, we already passed the terminal side. It's time to go back. How am I going back? Counterclockwise. Therefore, it's plus. And it's plus 45 degrees. So it gives us negative 315 degrees. Same way, you can go multiple revolutions in the negative side, and then at the end just add 45 degrees because that last part is a positive angle. The same holds for the radians. So nobody says that you only find coterminal angles in degrees. You can have them in radians. For example, if the angle is pi over 4 radians, again, sharing the terminal side. In green, you see that I go one full revolution and then I add pi over 4, and one full revolution is 2 pi in radians, which is the same as 360 degrees. So I write 2 pi and then I add pi over 4 because I'm moving counterclockwise and find the value. If I'm doing the negative coterminal, which is the red one, I go one full revolution in negative, so that's negative 2 pi. And then I go back on it, so I'm adding something, and that is pi over 4.